Hello, in this video on Rust we're going to take a look at mutexes in Rust. It's been a while since I recorded a video just because I moved house and everything was in complete chaos for a while. So we're going to look at basically getting threads to access shared data, which apparently you can do in Rust. Rust itself, because of its ownership mechanism, protects you from doing a lot of stupid things that you could do by mistake in other languages. If you've done multi-threading in any other language, you probably know that you can't just write to the same shared variable from multiple threads, even if you're just incrementing an integer. What happens is that behind the scenes the integer will get copied to a register, typically incremented there and then copied back. And if you have multiple threads trying to increment that integer, they're going to end up overwriting each other's efforts, and sometimes you get increments being skipped. So the rule is that if you're writing to some data from multiple threads, you need to somehow protect that data, typically with a mutex, so that multiple threads can't mess up each other's efforts and only one thread can actually write to the shared variable at a time. Another way of handling this would be to use some kind of integer in this simple example that is designed for kind of thread safe access. So Rust does have like an atomic integer type that you can use, and then you can write to that safely from multiple threads. But we're going to take a look at using mutexes, which is kind of the most general way of handling this situation. And the idea behind a mutex is that you have to lock it before you can actually write to the data it protects. And then you can't lock it from multiple threads, so that protects your data from getting messed up by multiple threads trying to do the same thing at the same time. So anyway, I've got some notes here which I've already written, and I might have to refer to these in order to get through this video, but I'll do my best with it. I have been through this stuff already because it is a bit complicated, and I'm going to take a look at this if I forget anything. But to start off with, I want to show you a really simple example of using a mutex in Rust. So at the top here, let's get rid of these windows that I don't need. I'm using a different computer as well. Hopefully the font size is okay, but you can let me know. So let's use standard thread. So just in case you're new, this is not exactly a tutorial. It's basically me working through the whole of the Rust documentation. I forget what it's called, the Rust book or something. Maybe that's something different. Anyway, I'm working through all the Rust documentation most of the way through it now, and I'm just trying to understand how it all works in a simple way. Okay, so I've imported standard thread mutex, and now I should be able to create a mutex. Let's say let m equal, I'll just give it a single letter name, mutex : new, and that can accept an initial value of some data that it's supposed to protect. So if we just want an integer here, and I assume this would work with structs and other things, but I haven't actually tried it. I'm just basically literally going through one page of the Rust documentation here and following their example pretty closely. Let's put 0 in there, and that's going to be the starting value of an integer. And now what we can do with this is we can lock it and access the value. So I'm going to try to remember this. Let's say let value equal m.lock. So that's the rule with a mutex. You have to lock it before you can access its value. And that actually returns some kind of thing that I've forgotten. I think it's a result that this returns. And the result contains some kind of poison error for if something's basically gone wrong. Or if things go okay, in the result there's going to be now what is that? I have to refer to my notes. Well, you can look at this page if you want. It's on blog.caveofprogramming.com. Yeah, mutex guard is the other thing that it can return. So if we get a mutex guard, that's a kind of smart pointer, and we can think, can we unwrap it? I've already forgotten, which is depressing. Let's do value plus equals 1, and let's see if this works. So my intention is to get the integer that this is guarding, and we're going to lock it so we actually get the value, and then we should be able to increment it, right? And then let's put a print line in here. Let's close this terminal if I can remember how to. I've actually forgotten. Okay, going to swap back to here. There we go. All right. So print line. It's been so long since I've recorded these videos. I've got a little bit out of practice with Rust, although I have been doing some user interface programming. I'm trying to get into that, and that looks really complicated, but I'll make some tutorials on it later on maybe. Okay, so we'll try to print out value here. Let's say value, and we're going to need some of these curly brackets, question mark, put the value in there. I think this is wrong, but I'm actually going to try it and we'll see. I'm going to clear that, and then am I in the right place even? So cargo run. Could not find cargo. That's a new one. I must be in the wrong directory. Let's go into the Mutexes directory that I created with cargo new and cargo run. Wow. Okay. Standard. Yeah, it's standard. Okay. Yeah, I missed off a colon there. Try that. Yeah, it's standard sync mutex. Let's try that. Give this a go. Yeah, can't increment the value here. Plus equals can be used on integer if you dereference the left hand side. Isn't that what I've done? Cannot use plus equals on mutex guard. I wonder what I did wrong here. I'm going to have to check my notes. Okay, I didn't get very far with this. Yeah, so we got to lock it and unwrap it and dereference it. All right, what's wrong with this then? Is it just that it's got to be mutable? Let's try that. No, that's really strange. Now I don't know what's wrong here. Okay, I want to check the top of the error. So create some blank lines so I can see where it starts. Right, it's actually quite a small error. Binary assignment operation cannot be applied to mutex guard integer. Cannot use plus equals on mutex guard. So we have got a mutex guard. We get that back from locking the thing. But then I thought we could simply dereference the mutex guard to get the value of the integer. So if you look at this, isn't that what I've done? Let mute value equals m.lock.unwrap, dereference it, and we should be able to, you know what, I've assigned here. I haven't incremented it. Maybe I actually can't increment it, and I don't know why that would be, if that's the case. But let's try that. So I'm just going to assign it some value, like for example 7, and we'll try that. No, that's not the issue here. Oh yeah, but now I've forgotten the dereference. Let's try that. Does that work? Okay, that does work. We've got value 7 coming out there. So, but we can't do plus equals or what? Let's try plus equals and run that. Oh, it works now. Okay, I am a bit tired. I just got something in the wrong place here, evidently. And I assume we could just do that again. So if I wanted to add something else to it now, after we've locked it, we can do what we want with it, basically. So that's all fine. But then look what happens if I copy some of this. In fact, I only really need to copy this line here. And I'm going to try to do it again here. And if we run this now, what should happen is it just hangs. So we're not seeing any output. We haven't even reached the print line. It's just hanging there. Because if you try to lock something that's already locked, then by default, the thread's just going to wait. In this case, the main thread is just going to wait endlessly, and it's kind of expecting in a way that some other thread will unlock this mutex. But since that's not happening, since the mutex is already locked, it will just wait indefinitely for this unlock to occur, which isn't happening because there aren't any other threads here doing anything with it. What we could do though is I could surround this by curly brackets. If I put a curly bracket there and another one here, I think, let's just do cargo format to save me having to indent that manually. And now what I believe will happen is there's this kind of, what's that acronym? Resource acquisition is initialization or something. So it follows that paradigm so that we get the lock and we've got this, this thing's locked. So we get the lock and it returns a mutex guard. And so that's actually a mutex guard, which is why we have to dereference it. The mutex guard implements the deref trait. And then when that goes out of scope, when this goes out of scope, it will automatically get unlocked. So then we should be able to lock it again and then the thread will proceed. That's what I think will happen. I am learning this as I go along though, so let's try this out and see if it actually does work like that. So cargo run. Yeah, now you can see that the thread doesn't hang anymore because this mutex actually gets unlocked when it hits that bracket and goes out of scope, and we're just creating a brand new mutex guard down here. Now what we should do is look at a more complicated example, and again I'm going to follow the example in the Rust documentation, because with this stuff I just couldn't really think of anything. It's a bit of a challenge to understand the Rust docs, to be honest. I'm very familiar with multi-threading, but everything in Rust does just seem more complicated. So what I want to do is create, like, let's say 10 threads, and then we're going to have them all increment a variable, and we're going to protect that variable with a mutex guard so that we can see what actually happens. So how do I create a thread? Let's do use standard thread. We covered this, I think it was the last video, but it is like, I don't know how long, is it a month or something since I created a video? So let's do let handle equal thread dot, is it thread : spawn, maybe, could be, and we pass that a closure, so I get a couple of bars here and some curly brackets. And what the Rust docs actually do on this page is it shows you the errors that you get if you try to do this in a naive way, in a way that doesn't actually work, and it kind of works through those errors and shows you how you can fix them all. And so that's exactly what I'm going to do now. I'm just kind of giving you my version of the Rust documentation. Okay, so what do I want to do in there? I want to mutex up here to guard an integer. So let's say I'll call it counter, which I think is what it calls it in a Rust docs. Let counter equal mutex : new, and we can set that equal to 0. And actually I want 10 of these threads, so I'm going to put them in a loop. Let's say for 0 ... 10, and put some loop brackets in there, and then move this inside the loop. So I'm going to be spawning 10 threads here, and this is apparently a perfectly reasonable way to do this. And now I want to be able to join the threads later on. So in other words, wait for them to finish. Otherwise we're going to get nonsensical results. So to do that, I need to be able to access the handles outside of this loop. So I'm going to add them all to a vector. Let's say I probably need to make this mute, but I'll just try it without. Let handles equal vec ! Square brackets, and then after I've got the handle, I can say handles.push handle. That's very similar to C++. And then down here, what should I just loop through them, can't I? So let's say for handle in handles, and I want to say down here handle.join.unwrap, and the entire purpose of that is just to wait for all of these threads to finish. Now in the actual threads, I want to increment that counter, so I have to lock the mutex to be able to use the value that it protects. So let's say let counter, I suppose. Wait, I've already called it counter though. Should I call it something else? Possibly. I'll call it M again. Then we know what it is. Let counter equal m.unlock.unwrap. Still not sure what I did wrong last time. Then I'm going to dereference that value and add 1 to it. I think that's similar to what I had last time. The only difference is we're doing it in 10 different threads. That should go from 0 to 9, and then we're waiting for all the threads to finish. So let's see what errors we get with this, and they are quite interesting, which is why the documentation goes through them. Maybe I can make that a bit bigger. Can I? Yeah, I've got a shortcut set up. Okay, I'll do cargo run, and missing, okay, I missed in from the for loop. So for, I don't want to use the value of the counter, so I'll just use underscore, which won't give me an unused variable message. For underscore in that stuff, let's try that. Okay, where did it start? It started here. No method named unlock. Yeah, I don't want to unlock it, sorry. I want to lock it. You have to lock it to get the value, and then the unlock will occur when it goes out of scope, when this goes out of scope. Let's try that. So I clear this, run. All right, so yeah, I think this is what I was hoping to see. So it's saying that whatever's in this closure may outlive the mutex, right? I think that's what it's saying, because so here we're spawning an independent thread. We don't know how long that's going to live for. Well, we do, but Rust can't guess, I suppose, exactly what you're going to do with it, and that might outlive this variable here. So to be able to use m in this closure, you have to move m into the closure. So the closure has to take ownership of m. Otherwise, how can Rust know that m is going to live long enough for this closure to actually be able to use it for its entire lifespan? So we put a move there, if you remember this, and that will mean that any local variables that are used in the closure are going to be moved into the closure, so the closure will take ownership of it. And let's take a look at what errors we get now. And so I'll run that again. Now it is saying in a previous iteration of the loop, the value, does it mention m? Yeah, m actually gets moved into the closure, so subsequent iterations of the loop cannot then move it. So like the first time we go through this loop, a closure gets ownership of m, but then the next time we go through the loop, m has already been moved, so ownership has already been taken by the previous iteration of the loop, previous closure, and the next closure can't get ownership of it. I think that's what's happening here. So we have to deal with that somehow, and the way you might think of dealing with it is by using a reference counter, which basically implements multiple ownership. So let's say use standard RC reference counter, and then we can wrap this in a reference counter. So we say RC : new, wrap the whole thing in that. And then we don't want to use the value of m directly here. We want to use clone on the reference counter, and we've covered this previously, to kind of get it's kind of, I don't know, it's sort of a reference to it, but you're allowed to have multiple ones of those somehow. So let's say let m equal m.clone. I think that's what I want. So we've cloned m, and then having cloned it, you'd think, well, now we can use it in here, but that also doesn't work. Let's take a look at why. So if I run this, it says that RC of a mutex cannot be sent between threads safely. And I believe the issue here is that you can't safely share a reference counter object between multiple threads. And we've got multiple threads going on here. Fortunately, there's an atomic reference counter. In the same way that we've got atomic integers that you can modify from multiple threads at the same time, they're made to be thread safe. We've also got an atomic reference counter. So instead of this, what we want is, we actually want something from the standard sync package. And I can include two things from that package if I put curly brackets around them and I separate them with a comma. So I want atomic reference counter, and we'll get rid of that. And instead of using RC new, I'm going to use ARC new, a new atomic reference counter. Now I think it should work, but that of course heavily depends on the extent to which I've memorized this successfully. So let's try it. Cargo run. Okay, so the vector needs to be mutable, which I kind of expected. I just wanted to try it without, just to kind of check my understanding there. Of course, we're modifying this vector. And if I run it now, what have we got? Okay, unused arithmetic operation that must be used? Why, we've got to use it. That's just a warning though. That's fair enough. Yeah, what I should do with it is just print it out, right? Can I remember this? Do we not have to lock it again down here? Let me refer back to my example that I basically just copied from the Rust docs. So here we go down here and we can see that, yeah, to actually get it at all, you always have to lock it. So even in the main thread, if we want to print out the value of it, we're going to have to lock it. So I'm going to do print line, and in there I'm going to put double quotes, and we'll say value is something in curly brackets. We want this : question mark. I did know what this did for a while, and now I've forgotten it again. But we basically use this for printing anything more complex than an integer. And then down here I should be able to do m.lock in the main thread dot on wrap, and probably need to dereference that. I'll put that in, see if that helps. And then let's do a cargo format. I haven't done that for a while. And then we can do cargo run. And what's this? So unused variable warning. The arithmetic operation produces a value. I used plus instead of plus equals. Let's go back there. What I meant to do from the beginning was plus equals. All right. So this Rust compiler, occasionally it does produce warnings that seem really cryptic to me, but usually that's just because I don't understand Rust well enough. And the warnings from it in general are extremely good. So let's run this. Cannot borrow as mutable. That's a simple issue with this counter not being mutable, I think. Let's try it again, and I think we are getting there. And finally it says value 10. So what we've accomplished is we've created 10 threads. They've all safely accessed the variable guarded by the mutex. They've all incremented it, and then after all those threads have finished, so we wait for them to finish, and then finally at the end we print the value, and we see that indeed it has reached 10 because 10 different threads incremented it by 1. Okay, that's it for this video. Some really useful stuff here, I think. Extremely useful. It's always good to know multi-threading. You do get like software developers. It's probably getting less common these days, but you definitely get software developers who know a language pretty well, but they've never gone into multi-threading at all, and it's a complete mystery to them, and they don't know how to use it. And I think it's relatively simple once you understand it. There are a lot of pitfalls in it. It's extremely useful to know. What's the expression? An extremely useful tool to have in your belt or something like that. It's very good to know this stuff. And in practically every language, it's full of pitfalls, and it's really very easy to create bugs with multi-threading code, as you may know. But Rust does definitely, I can see that this would kind of minimize the bugs that you could create, because Rust's ownership system does make it more difficult to create bugs with multi-threading than it would be certainly in C or C++ or something like that. Okay, so do check out blog.caveofprogramming.com. I put all my videos on there, as well as the actual code that you can see, and I'm going to put a GitHub link on there as well, so you can check the actual code if you want. So until next time, happy coding.